My name is Guzmán-Morales. I am very excited to be here sharing my research with all of you, which is titled Spatial Temporal Patterns of Water Clarity in Guánica, Puerto Rico, 15 years after development of a management plan. This work was done with my advisors, Dr. Roy Armstrong, Juan Cruz Mota, and William Hernandez. A little bit about myself. I am a Boricua. I was born in Guayanilla, Puerto Rico, and grew up in la ciudad del Rito, Lares, which is a small mountainous town in the middle or central part of the island. In 2019, I received my bachelor's degree in biology from the University of Puerto Rico in Mayagüez, where I'm currently pursuing a master's degree in biological oceanography or marine sciences. I am a member of the Bioptical Oceanography Laboratory, where we do research on using satellite remote sensing to study water quality trends in the oceans and the coast, specifically in Puerto Rico, in support of coral reef restoration and conservation. And in my spare time, I enjoy paddleboarding and doing stained glass art. So to introduce my topic, we have to talk about water quality and how it has been decreasing in the coastal environments due to human impacts. And in the right side of the presentation, you can see a depiction of a watershed, which is an area of land that drains all streams and rivers to a common outlet, which can be a bay or the ocean. And this is to put into perspective that whatever we do in the mountainous or higher parts of an island or country can and has an impact in the coastal environment. And recent studies have found that more than 80% of the wastewater we generate by human impact and activities are discharged directly to rivers and oceans without any treatment, introducing many pollutants. These here are some of the ways in which we introduce pollutants. It can be as common as littering or throwing garbage directly to a water body, or through domestic activities and the use of detergents, which alters water chemistry, but also through land development and alteration of river canals in support of industries and agriculture for irrigation, and also to provide water to coastal communities. So what was our motivation to do this research? The problem of decreased water quality in the coastal environments is that it has harmful effects on valuable coastal ecosystems such as the coral reefs, but it also has harmful effects on the quality of people's lives because it increases diseases such as diarrhea and skin symptoms commonly known as rashes. And the problem is that there have been ongoing efforts and management plans created and implemented to reverse the effects of decreased coastal water quality, but they are usually not evaluated. Which is the example of the Guánica Bay Watershed Management Plan, which was created in 2008 to protect the coral reefs adjacent to the bay from sources of pollution. And in the right side, you can see the map of the Guánica Bay Watershed, which is located in the southwestern part of the island of Puerto Rico. And this watershed is composed of 8 sub-basins, all of which drain directly to the Guánica Bay through the river, Guayanilla River. And some of the management actions suggested from the plan were restoration of the Guánica Lagoon, which is that bright blue area that you can see in the map. The Guánica Lagoon was drained in the 1950s to support agriculture, and as well as educate agricultures on best management practices to reduce the erosion and sediments arriving to the bay. And this plan has been implemented since 2016, but there have not been any evaluation, assessment or evaluation to assess whether the management actions have been effective in improving water quality. I want to note here that the management plan or the management actions suggested from the plan have been implemented but not in totality. For example, the restoration of the Guánica Lagoon is one of the management actions that has not been implemented. So we propose to evaluate the effectiveness of the management actions implemented so far using satellite imagery from MERIS and OLCI that are satellite sensors that were launched to study ocean color, which give you water quality parameters such as chlorophyll concentration, suspended particles, and light attenuation, which is the focus of this work. We wanted to evaluate the effectiveness of the management actions implemented in the Guánica Bay so far using remote sensing techniques. And for this, we described temporal trends of the diffuse attenuation coefficient, or KD490, which is a water clarity index in estuaries in the south and southwest of Puerto Rico. We expected that if the management actions implemented from the management plan had been effective, the diffuse attenuation coefficient would decrease in Guánica after the implementation of the management actions, and that this change would be observed in Guánica as compared to reference estuaries. And here you can see our experimental design. We used a beyond before-after control impact to sample our study. This method focuses on measuring the variable of interest, in this case the diffuse attenuation coefficient or the water clarity index, before and after a human impact. In this case, the managed versus not managed estuaries. The managed estuary was the Guánica Bay, and we selected 3 not managed estuaries or reference estuaries. And in each estuary, 4 locations were selected to observe the variability of each estuary, and they were selected in terms of proximity to the river mouth. For example, C means close to the river mouth, east, west, and far from the river mouth. And 3 pixels were randomly selected at each location. And this over here is a product for the diffuse attenuation coefficient for July 12, 2002. That is the island of Puerto Rico. In the southwestern part, you can see the Guánica Bay and the 4 areas selected within each bay. And the reference estuaries that were located in the south and southwestern part of the island, we have Guanajibo River in Mayagüez, Guayanilla Bay in Guayanilla, and Descalabrado River in Santa Isabel. And what I want you also to note here is that the KD values, or the water clarity index values, range from 0 to 1. The lower values are shown as purple or dark blue, and this means that light attenuation in those areas is less, which means that penetrates more in the water column. And this is because water are more clear in that area. And these are observed more in the open ocean. And then we have higher KD values observed here as green or yellow. And these are observed in the coastal zone because light is more attenuated, it penetrates less in the water column because it has sediments and riverine inputs. So here we have the results of the temporal patterns in the managed estuary and the not managed estuaries. What I want you to note here is that each estuary followed different patterns, which is expected because they are all located in different parts of the island. But I also want you to know that higher KD values were observed in the not managed estuaries that were Guayanilla, Descalabrado, and Guanajibo, meaning that these estuaries are more turbid than the Guánica Bay estuary. Like I mentioned, we expected the KD values to decrease during the after period of our study, and as you can see from the graph, they actually slightly increased during the after period. But also another interesting thing we found is that in 2018 we have a peak in the southern estuaries, and this peak is associated with the passage of Hurricane Irma in 2017. And you might be wondering why, if the hurricanes were in 2017, we see a peak in 2018. It has been shown that the effects of these hurricanes lasted for several months after the passage of the hurricane, altering the average of the 2018 year. And that's why we see a peak. The diffuse attenuation coefficient did not decrease in Guánica after the implementation of the management actions. This does not mean that they haven't been effective, but that the impacts of the hurricanes outweigh the impact that the management actions could have on improving water clarity. Some of the recommendations from this study were to reevaluate the plan once the Guánica Lagoon is restored, and implement management plans in other southern estuaries in the south and southwestern of Puerto Rico that had also very turbid waters, and continue educating the local community on the importance of improved water quality for the health of the community and for the health of coral reefs. This research was funded by NOAA and SACNAS, and I'd like to thank you all for listening, and if you have any questions or comments, now is the time. If you scan the QR code, you will find the research article, a story map on this investigation, and my socials. Thank you.
Thank you, Alba. We have plenty of time for questions.
Very nice talk. It's really interesting. And so, and you kept answering my questions that I've been building along the way, which was going to be about the impact of the hurricanes. So, have you thought about or tried for, instead of making an annual average, to break it up so that maybe you could tease apart when you're having those hurricane impacts versus when you're not?
We did. I didn't include them in the presentation or the article, but I did make like a whole by monthly averages. Yes, and you can see the dry period that is in Puerto Rico and the wet period, and the effects of the rainfall on the water clarity.
So if you take the window of time when a hurricane would go there, there's still an increase. It would be a decrease in transparency or an increase in opacity.
Yes. Every time the September, that period, the September usually has higher values because of the passage of the hurricanes.
Yep.
Yes.
Okay.
They do have an immense impact on water clarity.
Thank you.
And that's because landslides are occurring in the mountains, and they and continue happening, like I said, months after the hurricanes.
Yeah.
Any other questions?
I have a question. I noticed that a lot of those stations were on the west and southern part of the island. Can you tell us about the monitoring efforts, if any, on the other side where we didn't see those stations?
Yeah, I have, these images are for the whole island, so I could find what are the trends in other areas. But for this study, we focused on the south and southwestern areas because they have similar climates, basically, and we wanted them to be like comparable.